Welcome to this lesson on refraction. Today, we're going to explore one of the most fascinating phenomena in optics, how light bends when it enters a new material. This is called refraction, and it's responsible for many everyday observations, from why a straw looks bent in a glass of water to how our eyeglasses work. Let's dive in and understand the science behind this amazing property of light. So what exactly is refraction? Refraction is the bending of light when it passes from one medium to another. A medium is simply any material that light can travel through, like air, water, or glass. The key thing to remember is that light changes direction at the boundary between materials. This doesn't happen randomly. Light bends in a predictable way, and understanding this behavior is crucial for understanding optics. But why does light bend in the first place? The answer lies in speed. Light travels at different speeds in different materials. For example, light moves faster in air than it does in water or glass. When light enters a new medium where its speed changes, this change in speed causes the light to change direction at the boundary. Think of it like a car moving from a smooth road onto sand. The change in speed causes a change in direction, and the same principle applies to light. To quantify how much light slows down in a medium, scientists use something called the refractive index. The refractive index is a measure of how much light slows down in a medium compared to its speed in a vacuum. The formula is n equals c divided by v, where n is the refractive index, c is the speed of light in vacuum, and v is the speed of light in the medium. The higher the refractive index, the more the light slows down, and the more it will bend when entering that medium. Let's look at some common refractive indices to get a sense of how different materials affect light. Vacuum has a refractive index of exactly 1.00. Air is very close at 1.0003, which is why we often treat air and vacuum as similar. Water has a refractive index of 1.33, meaning light travels about 1.33 times slower in water than in vacuum. Glass typically has a refractive index of 1.5, and diamond has an impressively high refractive index of 2.42, which is why diamonds sparkle so brilliantly. Now let's talk about the mathematical relationship that governs refraction, known as Snell's law. Snell's law gives us a precise way to calculate how light bends. The formula is n1 times sine of theta 1 equals n2 times sine of theta 2. Here, n1 and n2 are the refractive indices of the two media. Theta 1 is the angle of incidence, which is the angle at which light hits the boundary, and theta 2 is the angle of refraction, which is the angle at which light continues in the new medium. These angles are always measured from an imaginary line called the normal, which is perpendicular to the boundary. Understanding how light behaves during refraction is straightforward once you know the refractive indices. When light enters a denser medium, meaning a medium with a higher refractive index, it bends toward the normal line. For example, when light goes from air into water or glass, it bends toward the normal. Conversely, when light enters a less dense medium, meaning a medium with a lower refractive index, it bends away from the normal line. So when light goes from water back into air, it bends away from the normal. Refraction isn't just a theoretical concept. We see it everywhere in daily life. Swimming pools appear shallower than they actually are because of refraction at the water's surface. A straw in a glass of water appears bent or broken at the waterline due to the bending of light. Rainbows form when sunlight passes through water droplets in the atmosphere, refracting and separating into different colors. And eyeglasses work by using refraction to bend light in just the right way to correct vision problems. Understanding refraction helps us appreciate these phenomena and design optical devices that improve our lives.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.